Hello and welcome to the second part of the June 2017 paper. As you know, we're doing multiple choice past paper questions, 30 questions at a time. I hope that you've already been through the 2020, 2019 paper, 2018, all the ones that we've done before. All right, so here we go. We are going from questions 31 to 60. The first one says, when 8 is subtracted from a certain number and the result is multiplied by 3, the answer is 21. What is the original number? Now you can just go ahead and reason this backwards so you can find the original number. But we're going to just write down this information in a mathematical statement using math symbols. When 8 is subtracted from a certain number, and then that result is multiplied by 3, the answer is 21. Right? So when we multiply 3 by the answer we get when 8 is subtracted from a certain number, the answer is 21. And so we'll solve this equation quickly. 3 times x, that's going to be 3x. 3 times negative 8, that's negative 24, equals 21. Adding 24 to both sides, we get 3x is equal to 45. Dividing both sides by 3, x is equal to 15. And you can always double check. When 8 is subtracted from 15, we get 7. Multiply that answer by 3, we get 21. How many kilograms are there in 1 ton? You just have to know. It's going to be 1,000. Number 33, there is a cube that has an edge of 3 centimeters. What is its volume? And volume is just calculated as the length of that edge times itself, or length cubed. So that's going to be 3 centimeters, and we're going to cube that. That will give us 27. Number 34, it says a car travels 80 kilometers in 2.5 hours. What is its speed in kilometers per hour? Speed. If you forget the formula for speed, it makes it easy if you think of kilometers per hour. Speed is distance, kilometers distance, divided by time, the hours there. So that's a formula for finding speed. And we know that the distance is 80 kilometers. We're going to divide that by 2.5 hours. Distance divided by time. All right, and we know that this fraction, 2.5, is the same as 5/2, writing it as an improper fraction. And then we continue. 80 divided by 5/2 is the same as 80 times 2/5. 5 into itself 1, we simplify. 5 into 80, 16. And that will give us 32. All right, so that will be the speed, 32 kilometers per hour. Number 35, we get a triangle resting on a square. It says the length of one side of the square is 5 centimeters. We should also recognize that this is 5 centimeters. And the height of the triangle is 4 centimeters. What is the total area of the figure? Now, the area of the triangle we're going to use here, since we have a base for it and also a height. The area of triangle is equal to half times the base times the height. The base of the triangle is going to be 5 centimeters times the height, which is 4 centimeters. You can simplify here. 2 into 4 goes 2 times. 5 2s 10. centimeters squared. And the area for the square is going to be length squared, which is 5 centimeters, times itself, which will give us 25 centimeters squared. Putting both areas together to find the total area of the figure, we get 35 centimeters squared. All right, this question we have done before. It says the area of a rectangle is 53.6 centimeters squared. And immediately you start to think about the fact that you know the formula for finding the area of a rectangle. If the length is multiplied by 4 and the width is half, what would the area be? So the area of the rectangle is 53.6 centimeters squared. And then it says, if we multiply the length by 4, so you immediately start to think of multiplying this answer here, 53.6, by 4 as well. Because if the length is multiplied by 4, your answer overall is affected in the same way, because this is multiplication. And the width is halved. That means you're dividing the width by 2. So your answer is also halved. What would the area now be? All right, so you're going to simplify this. You're going to evaluate this. 2 into 4 goes 2 times. We're in the paper 1 exam, so you are not allowed to use calculators. And then you just go ahead and multiply 53.6 times 2. As I said, you've done this question before, and I've encouraged you to practice multiplying your decimals. Our answer is going to be 107.2. Number 37, it says a man leaves home at 22:15 hours. You recognize the 24-hour clock, and reaches his destination at 400 hours in the following day, the same time zone. How many hours did the journey take? Now, this time here, what time would that be on the 24-hour clock? That would be 10 o'clock in the night. And if you need practice on reading the 24-hour clock, you can go ahead and do so. That would be 10:15. And 400 hours is going to be 4 o'clock in the morning. Right? How many hours did the journey take? And some persons will do this just using their heads, simply saying from 10:15 to 11 o'clock, that's 45 minutes. And then from 11 o'clock to 4 o'clock, that's 5 hours. So the entire journey is 45 minutes, and it's 5 hours and 45 minutes. And of course, we know that none of these are the answer. Of course, you know that 45 minutes out of the total minutes that make up 45 minutes as a fraction of the total minutes that make up an hour, which is 60, is going to give us 3/4. We were asked how many hours, so it's 5 3/4 hours. The distance around the lake is 8 kilometers. On a map, this distance around the lake is represented by a length of 2 centimeters. What is the scale on the map? All right, so the first thing we need to know here is the distance. The first thing that we need to compare is the distance around the lake in terms of kilometers and centimeters. And we're talking about in real life, not just on the map, all right? Centimeters, kilometers. No, I hope that you know how to convert your units. 10,000 centimeters is equal to 1 kilometer. Now, all of this is in real life. 8 kilometers is equal to a certain number of centimeters that we don't know. So we go ahead and solve this using the ratio technique that we've discussed before. So using the ratio 100,000 to 1, that should be equal to the ratio x to 8. All right, you're creating these ratios so you can easily find the cross products. All right, so we have x times 1, which is x, 8 times 100,000, which is 800,000. So in real life, the distance around the lake measures 800,000 centimeters. That was what we wanted to find. That's what x represents. 800,000 centimeters. But this length is represented on the map by 2 centimeters. Map, real life. Two centimeters to represent 800,000 actual centimeters in real life. Because of course, you can't draw all of that on paper. All right, so if we want to know what 1 centimeter represents, and that's what we're being asked here, to say how much 1 centimeters on the map represents in real life. All right, we know what 2 centimeters represents. All we need to do is divide 800,000 by 2. And what will we get? 400,000. All right. Number 39. The perimeter of a square is 56 centimeters. What is its area in centimeters squared? We have a square. What do we know about a square? You have to take into consideration the fact that all 4 sides have equal length. And if the perimeter is 56, what is the length of each side? 56 divided by 4. That's going to be 14 centimeters. And that is what we must know before we can find area. So area of the square is going to be length times length, which is 14 centimeters times 14 centimeters, which will give us 196 centimeters squared. For this one, we have a cylinder that has a radius of 3 centimeters, and you look on the diagram to verify, and a height of 8 centimeters. What is the volume of the cylinder? Now we know that volume is just area of the object times the height. Area of the cross section of the object. All right, so we have the circle here being the cross section. So area for a circle is pi r squared times the height. All right, so that's pi times r. What is r? The radius, 3 squared, times the height, which is 8. Multiplying all of this, you notice that pi should be left in your answer. So you go ahead and just multiply the 9 times 8, which will give us 72. That's 72 pi centimeters cubed. All right. And of course, if this were a paper 2, you would be, well, all the time, please be sure to put in your centimeters. All right, number 41. There is a histogram, and we've done this one before. Shows the number of children who took part in a survey. It shows their ages right here. And we're asked what is the modal age. That means we're looking for the age that occurs the most. All right, and as we can see here, the age that has the highest bar is going to be 7. How many children took part in the survey? All right, so we have 3 children here, 4 children here, 2 children, 5, and 1 child. And that should give us 15 children. Number 43, we have a question we've done before again, the frequency table, and it's showing the tests, the marks obtained by students in a test. We're being asked to find the range of the scores, and range simply is the highest score minus the lowest score. What is the highest score? 10. And the lowest score is 2. So our range is going to be 8. This one says if the mean, and we know that just means finding normal average, the mean of 4 numbers, 4, 8, 2x, and 12 is 10. And we're supposed to find x. Now we know that mean equals adding up the numbers and dividing by the number of numbers. Now they tell us that this is equal to 10. So we go ahead and don't stop until we have solved this equation, finding the value of x. All right, simplifying our right-hand side, the numerator, we have 12 plus 12. That's 24 plus the 2x that would have been there originally over 4 equals 10. Multiplying both sides by 10, by 4 that is, we get 2x plus 24 equals 40. Let's move over here. Subtracting 24 from both sides. All right, we will now have 2x equals 16. Be careful not to jump and go circle 16. All right, divide both sides by 2. X is going to be equal to 8. Number 45, it says of 120 students writing an exam, 100 are expected to pass. The estimated probability that a randomly selected student will fail the exam is, all right, how many students are going to fail if out of 120, 100 are expected to pass? That means 20 out of the 120 will fail. We simplify that to get 1/6. Which of the following which of the following diagrams best illustrates a function? And I think the very easy one to look out for here is this one-to-one function, one-to-one relation here. Please revise what are the different types of relations that are considered as functions. Number 47, the straight line AB cuts the y-axis at what point? We've done this before. This is the y-axis. It cuts it right here at 0, -2. Number 48, h of x, we have that function, and we are told to find h of -6. So wherever x is, we are going to put -6. So 3 times -6 minus 2 over 5. That's -18 minus 2 over 5. That will give us -20 over 5, which is -4. All right. This one says, we are given a number line, which shows the solution of an inequality. And we're supposed to tell which of these statements, range of values, represents what the number line represents. All right. Just bear in mind that these circles are open, they're not shaded, which means at no point we should be including signs like is equal to in our answer. Less than or equal to, greater than or equal to, those will not be in our answer. And so the answer is going to be D. X is greater than -2 and less than 3. The values of x, look at this graph, for which this graph intersects y equals 0, that line, and y equals 0 we know is the x-axis. At what points do those two things intercept? That's going to be where x is 0 and where x is 4. For this one, it says, we have a function here. Which of the following best describes the function? So you're going to test by using substitution. All right. Is f of x equal to x? Meaning, is the y value equal to x? No. We have x equals f of x, which is y, plus 3. Is that true? When x equals 2 and y equals 5, is this statement true? No, 2 is not equal to 8. Y equals y plus 3. Let's not even go there. Then we have y equals x plus 3. My x value, if I add 3 to that, do I get 5? Do I get the y value? Yes, we do. When x is 5, do I get 8 for y? Yes, we do. You can test them, substituting them. D is our answer. Number 52, it says, if each exterior angle of a regular polygon is 60 degrees, what is that polygon? All right. And if the exterior angle of a polygon is 60 degrees, then the interior angle is going to be 120 degrees because both of them must be supplementary. All right. And the polygon that has that is going to be a pentagon. All right. So you may want to revise the others as well. We have a pair of intersecting lines here, and we are asked to find the measure of angle ABE. All right. If we notice, DBA, that's this angle here, we're given 58 degrees, and ABE, the one we want, they're both sitting on a straight line, and so we know that those two angles should add up to 180 degrees. So if we should subtract 58 degrees from 180 degrees, what would our answer be? $122 degrees. We've seen this question before. Let's go. In the triangle, what is the value of x? Now, this is an isosceles triangle. And so we know that if these two sides are equal, then these two angles are equal. So we just need to find the third angle in this triangle. So that's 180 degrees, the total angles in the triangle minus both of these that we know, and that will give us our third angle. Angle 180 degrees minus 60 degrees, and that will give us 120 degrees. All right, this one says, we have the diagram of a straight line y equals x. What is the image of the line when it is rotated anti-clockwise about here, the center, through an angle of 90 degrees? And just picture it using your hand, taking up this line and just spinning it 90 degrees, which means this piece now ends up here, anti-clockwise, so you have to go that direction. All right, we'll end up here. And this piece will end up here. It's 90 degrees and you're going anti-clockwise. All right, and that is the line y equals negative x. Next, we've seen this one as well. A pair of similar triangles. What does that mean? The ratio of their sides and angles are equal. All right, you can tell that it's similar even if you weren't told, because all the angles are the same. The angles that are in the same position are the same. All right, so here we go. We need to find the length of MO. MO can be compared to the side 7 centimeters, which is AC. All right, they're in the same position. What are two sides that we know on the different triangles that are proportionate to each other? All right, that is going to be on the triangle on this side, that's going to be MN. And on the triangle on our left, it's going to be AB. All right. So while in the same way that 7 is related to 7 in the first triangle is related to MO in the second triangle, 6 in the first triangle is related to 3 in the second triangle. And we just want to find whatever MO is. Now we can go ahead and set up our ratios and use the cross products, make them equal, etc. We've been using a lot of that. We can also just observe and say if I divide 6 by 2, I get 3. So I can do the same here. If I divide 7 by 2, what do I get? 3.5. All right, for this one, we have a right angle triangle. One side measuring AB, that's the hypotenuse. And we have 30 degrees being right there at angle A. BC is then going to be our opposite side, which means AC is our adjacent side. All right. We are told to find the length of BC, that's the opposite side. So which side do we have the hypotenuse? Which side do we need the opposite? Which ratio do we know that has opposite and hypotenuse in it? That's the sine ratio. Sine theta is equal to opposite over hypotenuse. All right, so sine 30 degrees is equal to BC over the hypotenuse, which is 40. Clearly, we don't need to work out what sine 30 is, because we see that it still remains in one of our answers. All right, multiplying both sides by 40, we get BC is equal to 40 sine 30, and our answer is A. Right angle triangle again. AB is 17 centimeters, AC is 15 centimeters, BX is X centimeters. We're told to find X. We're looking at the relationship between three sides of a right angle triangle, which means we're going to be using the Pythagoras theorem, which says that the hypotenuse squared is equal to the sum of the squares of the other two sides. All right, so 17 squared should be equal to 15 squared plus x squared. That's not 389, but 289. So you do your multiplication, square 17, you'd get 289 equals 225. That's 15 squared plus x squared. Subtracting 225 from both sides. And we're left with 64. Square rooting both sides. We have x being 8. Because this is length, we don't need to say plus or minus 8. Almost there. We have a triangle PQR. Angle P is equal to x. And angle Q is equal to 2x. What is the size of angle R, the third angle? So we know that all the angles in a triangle add up to 180 degrees. And if we want to find the third angle, just subtract the sum of both of the other angles. X degrees plus 2x degrees That's going to be 180 degrees minus 3x degrees. That's it. You're not being asked to find a specific number. All right. And finally, a surveyor sets up his instruments 12 meters from the foot of a building, as you can see here. And he records the angle of elevation of the top of the building, right here, 40 degrees. An estimate of the height of the building is obtained by, and we're supposed to figure that out. All right. Please note that even though the angle of elevation is measured here, we need to remember that this also forms a part of the height of the building. So if we can find that portion plus this portion, then we should be okay. All right, please note that if this is 12 meters, then this is also 12 meters. All right, so we have the adjacent side of this right angle triangle, and we want the hypotenuse, we want the opposite side. All right, adjacent and opposite, which ratio involves both of those. That's going to be tan theta. So tan theta is equal to opposite over adjacent. That's going to be the side that we don't know. Let's just call it x over adjacent, which is 12 meters. Or we could have called it h, height, you know. So be tan 40 degrees. That height, the x, multiply by 12 to make x a subject. We're going to now end up with that height being 12 tan 40 degrees. But of course, that's not the only part of the building. We also have to take into consideration this 1.6 meters. So it's 1.6 meters plus this. And that is the end of today's video. I will see you next time where we will be doing the 2016 paper 1 part 1.